It was a professor. It's me, Ryan. So let's get started. My first test question I messed up because I just messed up. It was a vertical asymptote question. I was probably just it was probably a dumb mistake. Like I just didn't catch it or something. Maybe it was like too early in the morning. But the way you find the vertical asymptote is just you take whatever the denominator is and you set it equal to zero. Um, I honestly don't know how I let a mistake like that happen. That probably won't happen again. But for an example, it would be like if the denominator is x minus 4, the vertical asymptote is just 4. So, yeah, hopefully I don't make that mistake again. Second question, let's see, um, create an exponential function with the following properties. It has the horizontal asymptote y equals 3, range of negative infinity to 3. Uh, so, basically for this, I made this function negative 5 times 2 to the power of x plus 3. So basically, the negative 5, you can put any number you want, but it has to be negative, and that's for the range. The range is negative infinity to 3. The reason why it's to 3 specifically is because of the final plus 3 over here. The 2 to the power of the x is what makes it exponential. That's just that property of exponential functions, I guess. It's just how it is. I don't know how I explain it further. If you just pop it in a calculator, you'll in a graphing calculator, you'll just see the graph is exponential whenever it's like that. And then the plus 3 is not only for the range, but it's also because the horizontal asymptote will just be 3. So that's how I got this equation. Now the question 3 is a little long to explain. Actually, it shouldn't be that long to explain. First, I had to find h, which wasn't that bad. It's just negative b over 2a. So I did negative b over 2a. I got 1.5 or 1 1/2. I then that equals the seconds the ball is in the air. Or no, oh no, sorry. That equals at what seconds the ball is at where. How I found the where was I just put it into the second equation, rewrite the function in the form, and then I found k for that equation, and the k is 324 feet in the air. That also represents the y, and the 1.5 represents the x. It's like a parabola, and that's like where the parabola kind of like hits the vertex is what it's called. And then maximum height was what I just said, 324, and the ball hits the ground. To find this, at first I thought it would just be like 3 because it's just like 1.5 and then another 1.5, but no, it's actually 6 because I just set the let me see, I set the forgetting what I did. Wait, I set what did I set equal to 0? I set the function equal to 0. Yeah, sorry. I zoned out there. I set the function equal to 0 and I got 6. Um Exponential functions can be modeled. Oh yeah. So question 4. This one was also a little complicated, not too complicated. Um the orange, sorry, this picture's kind of not the greatest, but the orange is like the plotted, and then the black one is the actual function I wrote. So, let's see. Yes, I plotted them. Yeah. Do the points look like it did look like an exponential function. Try to create a function that models the data. Okay, I remember. Um, so first to find a, I I got 1.5 because let's see. F0 equals a b so I set f equal I set x equal to 0. So it would be f0 equals a b to the power of 0, and anything to the power of 0 is 1. So I got a times 1, which is 1.5, because a is alone, and f 0 is a. And on these, when x is 0, y is 1.5, and that's just like how a function is. It's fx equals y. So I got 1.5 there. And then to solve b, I did f and then 1. I put a back in, but as 1.5. And then b to the power of 1 is just b. So then it's just 1.5 b times b, but then over 1.5, and that equals that ended up equaling 4.07. So then the final equation I got was y equals 1.5, and then in parentheses 4.07 over 1.5 to the power of x. And then yeah, I solved that. And then plot your function with 100% match the data. Why must it be an error? It is not 100%. It's very close. And I said it's an error because at the very start of the question it says it can be used to model certain situations. So I'm guessing these like points are from like a real life situation, and then what I did was like mathematically solve it. So I guess in real life it's not always gonna be like exact, but then when you plot it mathematically, it's exact. Yeah. But that's it, I believe. Okay, so thank you for listening. Thank you for your time.